Good morning. It is Tuesday. It's 8:15, and I'm doing this recorded live lesson while no one's around, so they can't laugh. So here we go. Bear with me. It may be rubbish, but we'll see. So the focus for this is upper and lower bounds. It's a new piece of learning. It was on last week's exam papers. For those of you who did them, if you didn't, boo. It's kind of grade 4 area. So let's get going. 42 is the number. If I said to you, give me that number to the nearest 10, what would that be? And I'm hoping you're going to say 40. Now, let's imagine you were given 40 was a rounded number to the nearest 10. What are the possibilities? So, you know that 40 was a number that's been rounded. What could that number have been? Well, let's have a think. Hopefully you appreciate it could have been 39, because 39 rounds up to 40. It could have been 38. And how far back can we go? Well, hopefully you appreciate you can go to 37, you can go to 36, and you can also go down to 35. But if you go to 34, that's going to go down to 30. So 35 is the smallest number it could ever have been. And that smallest number is what we call the lower bound. Now we're going to go the other way and think about what's the biggest number it could ever have been. So it could have been 41, could have been 42, could have been 43, could have been 44. And then next, where do we go? 45? Can it be 45? Well, if you go to 45, nearest 10 would be 50, because if you're at the halfway marker, you round up. So, what's the biggest number I can get to? Because I can go past 44. So I can go to, for example, 44.1. I could go to 44.2. If we keep going, hopefully you appreciate I can get to 44.9. But can I get bigger than 44.9? Well, yes, I can. I can get 44.99. Can I get bigger than that? Well, if you're on fire this morning, 44.9 recurring. How do you indicate recurring? Well, you do that with the dot notation. So the biggest number it could ever have been is 44.9 recurring. So be aware of that. But when it comes to recording upper and lower bounds, we're going to show that 40, I'll go back to the colour. So 40, and we're going to use our inequality notation now. So 40 could be greater than or equal to 35. So we can include 35, that's the lower bound, but it's got to be less than 45. We can't include the 45, and you just know in your head that the biggest number there is that 44.9 recurring. Let's go for another example. Let's give you 300, and this time this number has been given to the nearest 100. So, how small can we go for a number that rounds up to 300 as the nearest 100? Well, I'm hoping you realise that you can go all the way back to 250. Any number that's smaller than 250 will go down to 200. And thinking about going the other way, the upper limit is going to be, yeah, that's it, 350. Now, of course, we can't include the 350. Any smarty pants watching the video, what's that biggest number? That's not 350, but it's the one just before it. So we're talking 349.9 recurring. That's the actual biggest value. So again, when we record this using inequality notation, so 300, anything from greater than or equal to 250, that's your lower bound, and then less than 350, because that upper bound is 349.9 recurring. So there you go, upper and lower bounds. Getting the idea? Good, fab. Let's go to another example. This time we'll do it with decimal places. So if I gave you a number which was 26.2, and I tell you that is accurate to one decimal place, what's the upper and lower bound? Top tip here is, if I've given you a number to one decimal place, think about the number line that exists for all numbers with one decimal place in them. So number lines near to here with one decimal place, well, we've got 25.9, 26.0, 26.1, 26.2, 26.3, and so on. So all of these are one decimal place numbers. We're focusing here, 26.2. This just helps you think about the upper and lower bounds. So the question is, how far back can I go from 26.2 and how far forwards? Well, if you've spotted it by now, we're looking for that middle figure between 26.1 and 26.2. So the lower bound would be 26.15, and then the upper bound is 26.25. Bit trickier, but can you think about what the actual number is for the upper bound? Because of course we can't include 26.25 because that would go up to 26.3. So what's that number just before 26.25? So 26.2, well, before 25 is 4, but I can get bigger than 26.24, 249 recurring. So that's the real upper bound figure. That's the biggest value you can get to. Again, recording things using inequality notation. So we've got 26.2. That's got to be greater than or equal to 25.9, which is the lower bound, and that's got to be less than 26.25. Okay, so there you go, upper and lower bounds. I've now set you on your WeDuck platform 2 sets of questions, some involving rounding to the nearest 10, 100, 1,000, and then thinking about upper and lower bounds. And then the second part of it is where you're given a question to a degree of accuracy, and then you've got to work out what the upper and lower bounds are. I've shown you how to set out those questions. You choose 5 from each of the sections, so you don't need to do the whole lot unless you think you need the additional practice. And once you've done those highlighted questions in yellow on the worksheets, send that through and I'll give you some feedback. I'll tell you now, the trickier questions will be the ones where it talks about significant figures. So if you've got any questions on those, fire them through on the email. I'll happily answer those. And what I'm going to try and do is set up kind of like a question and answer session later on this week, so you can tune in and just fire some questions in relation to this particular piece of work. I'll also set some additional work on exam paper questions. So, upper and lower bounds, enjoy, and hey, not bad, first live recorded lesson. See you soon.